Okay, so for disks, I locate the circles along the axis I'm rotating around. That's how the circles are created, right? If I rotate around the x-axis, I've created a circle at that x location. That's why for disk method, it'll be integral dx if I go around the x-axis. For shell method, if I go around the y-axis, it'll be dx because I locate the rectangles along the axis that's perpendicular to. I want my rectangles to stand next to, stand parallel to the axis I'm rotating on. So how do I find them? I find them on the axis that's perpendicular to the one that I'm rotating on. Yeah, you don't have to draw any 3D. You don't actually have to draw on the rectangle. But to be honest, it's not a bad idea.
Well, I was just more so wondering because, how we've done the left-hand points, right-hand points.
Oh, no. Yeah. Good point. That's not what this is leading to.
Okay.
What that does for me is it helps me remember, okay, I know it's going to be, I'm going to locate it along the x. So what's the radius now? See, if I draw myself just an arbitrary rectangle, the radius is going to be from the axis out to that rectangle. So what's the radius? X, right? So I'm going to use the 2 pi RH dx. So 2 pi, the radius is x. What's the height of that rectangle? How tall is that rectangle? How tall is it? Yeah, totally. 2x squared minus x cubed. How tall is going to be how far away that function is. Like we saw back in the day. I mean, that's all there is to it. Don't make more of this than it is because it's already not easy. But it's not quite as hard as you think sometimes. And this is just new shit. So I got my 2 pi RH dx. Bam. Do you notice something nice about shells? There's no squared thing. Right? That's kind of nice. Because the squared thing is what makes the work that much more with the disk method. So now, how do I do this? What do I have to do first? Just distribute this right. And then I can integrate that easy. This will be 2, well, let's just cut to the shit. X to the 4th over 2 minus x to the 5th over 5. Since it's polynomial, the 0 part doesn't affect anything. So now if I just plug 2 in, I don't even want to finish this out because this is just numbers. Who cares? So when I plug a 2 in, I'll get 16 over 2 is 8 minus 32 fifths. 0 just makes it all 0. Maybe. So, looking at that, at this sheet, now I want to kind of see if you can pick up on what I'm trying to help you with. So here's I'm rotating around the x-axis. I locate the circles on the x-axis, and that's why disk, in this case, would be integral dx. Washers aren't really a new thing. They're just the difference between two disks. That's why it's pi r squared minus pi r squared, the outer one minus the inner one. It's really just disks. So they wanted to call it something else just to make it feel like there was all this new shit, but no, it's old shit. And then shells, I try to show you what's important. You got to figure out what the radius is, what the height is, and the thickness is going to be based on which axis am I rotating around. If I'm rotating on the y-axis, it'll be dx. The x-axis, it'll be dy. It's the reverse of disks, which is why shells works when disks don't. Because it allows you to use the other thing, dx versus dy. Okay, so I tried. It's not a bad idea to read through this. I try to recapture some of the stuff. In the shell method, the rectangles are located on an axis perpendicular to the one they rotate around. And that's why I'm allowed to use the opposite D thing. Discs, they're located along the axis I rotate around. That's why that has to agree. So looking at this last thing up here. Oh, everybody's left and I still have a practice test to give you. Too bad for them. Looking at this, it's not impossible to solve, but what is the functions, what are they in terms of as they're given to me? They're in terms of what? They're in terms of x. And I'm rotating around, what did I say here? About the y-axis. So if I didn't feel like changing those, if I wanted to use disk method, what would my integral have to look like? Integral d what? Rotating around the y-axis. So my disk method would have integral d y. Disk method, they agree. Shell method, think about this, was created so you're allowed to do the opposite of that. And why in this case, if I'm going to be lazy, why would I not want to use disk method maybe? I don't want to solve these. They're functions of x, so I wouldn't want to try to do the integral that needs dy. Right? Does that mean it's going to work? No. Let's set it up and see. So if I use shell instead, then it could be integral dx. And here's the, so now watch this. Let's do this. Okay. And then I might let us out of here. Yeah. This is why you should draw the rectangle in. You ready? What axis am I rotating around? The y-axis. So my rectangle should stand. If I'm doing shell method with the x-axis, my rectangle should lay down. I always locate them so that they stand parallel, but I locate them perpendicular to what I'm rotating around. So I'm rotating around this, so I want them to stand up. So if I draw myself a rectangle, I can see how tall that rectangle is. Because one thing I need is the height. So let's see, it's going to be 2 pi. I've chosen to do shell method, so that means it's going to be dx. That's one of the most important things. Now I know what the limits are going to be. What is x doing across my region? X is going from what to what? From 1 to 2, right? That was nice. It gave you the picture so you didn't have to do the algebra to figure out that stuff. And then what do I need inside? I need the radius. Well, what is this? So if I draw that rectangle, I can then find out how far away from this is it. Well, for any rectangle I want, how far away is it? The only time it won't be just x or just y, if I was doing it this way, is if my axis of rotation is not y or x-axis. So how far away from the y-axis is this x value? Well, it's x away. Of course it is. If I was rotating around this axis, it's going to be a little more than just x. It might be x plus 1 or something. And again, this is new. This is new, so you don't give up on it immediately. Start to see what's important. So there's my radius. What else do I need? I need my height. How tall is this rectangle? How tall is this rectangle? So it'll be this minus this. Well, what's this? Square root of x minus 1. And what's this? X minus 1 squared, right? Now, do you see how that looks like maybe I don't want to do this method, maybe? Do you guys see that? And I tell you to try both. You have to understand, this is something you should have gotten used to in pre-calculus. When you're doing trig identity, you try to do it one way, it ain't going to work. Okay, that's all part of the process. Do I want to do this integral? No. So now maybe I'm like, well, maybe I should go back and not be so freaking lazy in the first place. If I solve these for x, maybe the other method is easier. Now, to be honest, is it impossible to do this integral? No. You can actually use some u sub, and I showed you how you can be kind of flexible with the u sub. This integral will work. It isn't all that terrible. But if you do set up something doing one method and the integral is like impossible, well, then you go back and set up the other method. That's just part of the process. Okay, so let me give you guys the practice test. We're not going to, I'm going to do up through 6-3. We're not going to do, even more new stuff after this. So this next test is going to go up through 6-3. Oh, and I forgot, well, I think, what was it? Oh, Newton's method will be on here too. I just forgot to grab Newton's method from another practice test and throw it on here. Yeah.
So where is the test for?
Say again?
Where is the test for?
When's the next test? Next Thursday. Yeah. There's never any surprises, as I told you in the first day. Yes.
Can I write down a website that has been very helpful for me?
Sure.
In terms of understanding the material much better? And I thought maybe you guys all, if you're interested, I went from getting like not A's to getting A's on quizzes because of this website. So, if you want to know.
Yep. Is it done like Barnes & Noble for study guides? They have a ton of yeah, okay. See, that's a smart thing to do. YouTube, you can search for specific topics. You could look in their washer method and watch a few until you find somebody who makes sense. If I'm not making any sense, that's always a possibility. There are tons of videos of other people. Oh yeah, Paul's notes are good.
Can you read that?
If you shoot it to me, Shannon, I can email them out.
Okay.
Paul's notes are really good. I don't know if anybody's ever stumbled across Paul's notes.
They are really good.
Yeah. Because if you think any math course, you're going to get everything you need in the class time itself, that is insane. I do have office hours. But like Shannon said, if I don't make any sense, then there's all kinds of other resources. And that's what you do. Just try to find something that actually makes sense. I like it. Okay.